Hi, I'm Jan Ozer. Thanks for watching today. I'm from the Streaming Learning Center, and here's contact information, which I'll also present at the end of this presentation. And here I'm going to talk about two reports that I produced in August of 2022 that tested cloud-based per title encoding capabilities for H.264 and HEVC. So here's an overview about the Streaming Learning Center and myself. The Streaming Learning Center was created by me in 2011. It incorporates content and training courses for streaming professionals. So here you see 3 courses: Streaming Media 101, Introduction to Streaming Media, which is a free course, and Encoding with the AV1 codec. And I think there's about 6 or 7 courses. This is just the most popular 3. There's also frequent technology analyses and reports. So the H.264 and HEVC reports are not the first that we've produced. We produced many over the years. A little bit about me. I started encoding video in 1994. I've been a contributing editor to Streaming Media Magazine since 2005, where I focus on codecs and per title encoding. So here are some recent articles that I wrote on SVT AV1, a buyer's guide for per title encoding, another article on per title encoding defining how it works, and testing the newest crop of MPEG codecs, including LC-EVC, EVC, and VVC, comparing those to H.264, HEVC, VP9, and AV1. Recently, I joined NetInt as Senior Technical Director for Video Marketing. Although the Streaming Learning Center continues to remain open, the courses are still available, and I will still be writing for Streaming Media. A little bit about the reports. There are 2 reports, as I've mentioned. They were for H.264 and HEVC. There are 5 vendors that we compared: AWS Elemental Media Convert, the Bitmovin Cloud Encoder, Brightcove, the Zencoder encoding service, Azure Media Services, their encoding service, and of course Tencent. I tested 23 2 to 5 minute files in 4 genres: entertainment, sports, animation, and office files, screen cams and the typical talking head that you might see in training or corporate communications. I measured 11 different features of all the services, including the encoding controls, encoding cost, storage cost, top run quality, top run consistency and accuracy, ladder integrity, ladder construction, streaming bandwidth, VMAF quality, 99th percentile, and low frame quality. And then I measured the costs and quality over 3 different distribution patterns. And when I say distribution patterns, I mean top-heavy distribution pattern. This might be in the Far East, in Asia, in Europe, in the United States, where there's a heavy concentration in the top to middle of the ladder. So most of the rungs being delivered are in this range. Mobile, there's more of a middle concentration. And then IPTV, which is delivered via closed service on a very high-speed network, where all of the files delivered are from the top 2 rungs. Now, why did I look at the different distribution patterns? Because results are going to be different depending upon the pattern. If you have a very good encoding ladder, but mediocre compression capabilities, you may do well in the mobile ladder because you're going to have a lot of rungs in here for those viewers, and they're going to be properly configured from a resolution perspective, but you won't perform well in IPTV because you're just not that great from a pure compression perspective. And you'll see what I mean in a moment in terms of how I dealt with the 3 different distribution patterns. There was one overall winner, and given where I'm talking today, I'm sure you can guess who that would be, and it was Tencent Lab, who really did just a great job in pretty much every distribution pattern for both codecs, and you'll see results like that in a moment. So when I talk about distribution pattern and presenting results for each pattern, this is what I'm talking about. So this is top-heavy distribution, one of 3 for the HEVC codec. And here we see the 5 services, and I've divided or rated them on these 6 different metrics that kind of encapsulate both the cost side and the quality of experience side. So on the cost side, and obviously anything in green is going to be the best score, anything in yellow is going to be the worst score. And this is how Tencent did. They had the lowest overall storage cost here. The encoding cost wasn't the lowest, but it was pretty low. I think it was the second lowest, meaning the second best in this particular category. And in terms of streaming cost, it delivered the lowest streaming cost. Basically, that means that your cost will be significantly lower if you distribute via the top-heavy distribution pattern with the HEVC codec if you choose Tencent as compared to any of the other competitors. What about quality? Tencent delivered the best overall VMAF quality and stepped back into the pack a little bit with 99 percentile, which is a measure of quality consistency, and low frames, which is a measure of the propensity to have low frame issues or transient quality problems in your video files. Now, why buy the reports? For each codec, you learn which service gives you the lowest encoding cost, lowest storage cost, all the things you saw on the previous slide. So that's kind of the value proposition for the reports. Let's take a look at why Tencent did so well in both reports. And first, let's cover the scores. How did Tencent do in terms of suitability by distribution pattern for the H.264 codec? In terms of the top-heavy distribution pattern, they rated excellent. Mobile distribution pattern, they rated excellent. And IPTV, they rated excellent as well. And for HEVC, it was excellent, excellent, and strong. And these were the best scores in both codecs. That's why I called Tencent the overall winner. So why did Tencent perform so well in these reports? What did they do better than the other technologies? So it comes down to two things. One is the encoding ladder, and you can't produce good per title content unless you produce a very effective encoding ladder for each individual piece of content. I mean, that's what per title is, right? I mean, it's producing a unique encoding ladder for each piece of content. And our content ranged from, a simple PowerPoint file, which has a very low bit rate, to, very, very high motion sports, which had a very high bit rate. And you had to customize the encoding ladder for each bit of content. And as I'll explain, Tencent did an excellent job of that. The second factor, which we'll look at in a moment, is you have to have excellent compression capabilities, and Tencent did an excellent job at that as well. So how did Tencent create the encoding ladder? They start and choose the top rung via artificial intelligence, targeting a VMAF score of 95. Why 95? Because 95 has been shown to be indistinguishable quality from the source. So why go higher? Any additional bit rate is going to be wasted because the viewer won't notice the difference between that and a VMAF quality of 95. So targeted 95 and was very effective at hitting that target. And then for the next rungs, it divided the bit rate of the top rung, in this case, to go to the second rung, by 1.8 to identify the proper data rate, and then encoded using the source resolution of the previous rung and one lower resolution. So this is an example. So the top rung for this particular file, Tencent found to be, the best quality, or with a 95% VMAF score, was around 2200 kilobits per second. To get to the next rung, they divide by 1.8, which gives you around 1400 kilobits per second. Encode at the source resolution of the previous file, 1080p, and the next lowest resolution, in this case 900p. Measure the VMAF score of the two files and choose the VMAF score, or choose the resolution that delivers the highest VMAF score in that particular case. So in this case, it was 1080p also gave you the highest VMAF score. That would be the rung in the Tencent ladder. And then rinse and repeat for the next rung, rinse and repeat for the next rung, and then encode the lowest rung at the lowest specified resolution, which for these tests was 360p. So you had to have one rung at 360p for reasons explained in the reports, and then you had to start out at the highest resolution, usually 1080p, which was all the files' resolutions. So what did this add up to? It takes the guesswork out of encoding ladder creation. Now, both of the reports compared all the contestants to an ideal ladder that I produced using Netflix's convex hull analysis. So here, using the convex hull, which theoretically produces the ideal encoding ladder, because basically what you do to produce the convex hull is you encoded all these bit rates, all these resolutions, and choose the highest VMAF score at each resolution, for each rung. Pretty similar to what Tencent did, except this is a very brute force analysis. All these numbers were files that I produced and measured to produce the ideal convex hull ladder. What Tencent did is they produced a ladder that's very similar to that, using a very, much smaller set of encodes. And because their pricing is so inexpensive, the overall price to produce the files were not that dissimilar from the other services. So this is a brute force representation of the convex hull, and this is how Tencent did it, which was much more efficient. In the meantime, however, you see that Tencent's ladder very closely matches the convex hull ladder. Now there's one ladder, Bitmoven, that did a slightly better job matching the convex hull, but Tencent was right there with the convex hull, which means if we're measuring against the convex hull, it's going to be very close in that analysis. And then Tencent also excelled in pure encoding performance. So this is a static analysis. So I tested 23 files using the per title techniques, and I also tested 5 files to the same encoding ladder because I wanted to check the pure compression performance of each technology. And what I found for both HEVC and H.264, and we're looking at H.264 here, is that Tencent had the best overall compression of all the technologies that I measured. And it wasn't really even that close. Here we see a significant margin between Tencent and the other services, which are kind of clumped in here, except for AWS Elemental, which is a bit lower. And again, I measured 5 files using a static encoding ladder, and Tencent rated by far the highest for both H.264 and HEVC. So it's a pretty simple formula. If you have an excellent encoding ladder, which Tencent had, and you have the best overall compression quality, which Tencent had, you're going to be the overall winner. And that translates to the lowest possible storage and bandwidth cost, very high overall quality of experience, irrespective of where you watch your video. So if you're watching on your smartphone, if you're watching in your living room, or if you're watching on a computer, Tencent is going to deliver the best overall quality at the lowest overall cost, at least from a storage and a bandwidth perspective. More information on the reports, check out this URL. Here's some details. If you want to go straight and get and buy them, that's okay too. Here's the information you need to do that. I'm Jan Ozer. Here's how you can contact me, and thank you for watching.